Hey everyone, I'm Daniel. I'm converting a 2001 Jeep Cherokee from a gas-powered car to an electric car. I've always had an interest in building things, especially mechanisms that involve electronics. Building a computer, electric skateboard, and electric bike are some of my previous projects. I felt that I was ready to undertake something a bit more complicated this year, and that's what led me to this quest. I stumbled upon a 2001 Jeep Cherokee and thought it would be a great car to convert to electric for this project. One of the main reasons is that it's relatively easy to work on. This is because it's a 5-speed manual, which means that the way in which the transmission works with the engine is almost purely mechanical and therefore much easier to take apart and put back together than an automatic with a lot of ancillary electronics. This car is also an older car and is therefore more simple in general, as it has less additional features and sensors that you might find in more modern cars. Furthermore, this car was fairly inexpensive when I got it because it didn't have a working engine. In a simple explanation, converting a car to electric involves taking out the internal combustion engine and swapping it with an electric motor which is mounted and mated to the transmission. Then, batteries are wired to become the car's primary power source, replacing gas.
Here's a very simple diagram showcasing the system that one might find in an electric car. As you can see in the top left corner here, there is a main battery pack that supplies the majority of the power to the car. This power runs through a fuse that goes to the main contactor. And basically what the main contactor does is that it connects two wires together when prompted to complete the electrical circuit in this system, allowing power to run from the batteries and into the system. This contactor is controlled by various switches that are powered by the 12-volt battery in the car. These switches include a key switch, which basically turns on the car by engaging the main contactor and effectively allowing power to flow through the system. And then other switches such as the inertia switch and emergency stop buttons basically stop the car in the case of an emergency by disengaging the main contactor for safety purposes. The 12-volt battery also powers other electronic systems in the car like it typically does in any car, such as the headlights or dashboard, among other things. One thing that isn't depicted in this diagram is that there is also usually a DC to DC converter, which basically transfers power from the main battery pack to the 12-volt battery and keeps it charged. Once this main contactor is engaged and the car is on, power travels through the main contactor and to the motor controller. The motor controller receives a signal from a potentiometer, which is depicted on the right here, and the potentiometer is essentially attached to the gas pedal in the car and tells the motor controller to send power to the motor when the gas pedal is pressed. So obviously the motor is wired to the motor controller and receives power when the gas pedal is pressed, allowing the car to move. I've acquired a few of the key components in an electric vehicle so far, and I hope to ideally wire them up shortly. So these components include a DC series wound motor on the right here, a motor controller, and some smaller parts such as the main contactor here depicted in the bottom left.
The majority of what I have accomplished in this project so far involves a lot of research about the electrical systems and the components in an electric car, removing the engine in the Jeep, and acquiring the majority of the electronic components needed for the conversion. Through this, I have learned a lot, and some of the main things I have learned about include largely how cars with internal combustion engines work, electrical systems and the components that power these systems in electric cars, and how to deconstruct a car using proper tools and techniques. I started by removing various parts from the engine bay of the car that I wouldn't need in an electric car. This included engine filters, coolant systems, the radiator, alternator, etc. This took much longer than it should have because, again, I had no experience with cars before this project and I was still familiarizing myself with the different parts and tools. I found I had the most trouble disconnecting the fuel lines and fuel manifold from the engine, as there were certain bolts that were very hard to reach. Overall, however, I was very surprised by just how much of the car I could take apart with a few simple tools such as a socket wrench and some penetrating oils such as liquid wrench. This has probably been the most surprising part of the project so far. After this, it was time to remove the engine. With the help of a few others, we used an engine hoist to extract the engine from the car. And originally, we were going to unbolt the engine from the transmission and only lift the engine out. However, the transmission was very difficult to detach from the engine due to a few almost inaccessible bolts, and therefore we had to remove both the engine and the transmission as a unit. Overall, I've had a ton of fun doing this project so far, and I just want to give a huge shout out to my mentors, Glenn and Kevin. Glenn has taught me a ton about how cars work because I had really no knowledge of cars before this project, and he's given me a lot of advice on which car to pick, as well as just the first steps to deconstructing and putting a car back together. Kevin has done an EV conversion that he was able to show me, which was really awesome and informative, and he's been really helpful in just helping me to pick parts, troubleshoot issues, and has had a lot of electric vehicle knowledge that he's been able to share with me. I want to be able to educate other people about EV conversions with this project and hopefully inspire other students like myself to take on engineering projects to support a greener future. So stay tuned for more videos and updates on this EV conversion project along the way. And if you would like to support this project even further, feel free to visit my GoFundMe page that I will have linked down in the description below this video. Otherwise, thanks for watching and stay tuned for more videos.